Salam sejahtera. My name is Teresa, Susila, Anak James from Polytechnic Kuching, Sarawak, together with my friends Antoinette James and Kelvin Josejo from University Malaysia Sarawak. We'll be presenting dual function landfill leachate treatment using series configuration microbial fuel cells, or also known as MFC. For today's presentation, I will include introduction, literature review, methodology, result in discussion, and also conclusion. Let's go into the introduction. Leachate is the result of the accumulation of solid waste that includes unnecessary material created by human activities. For instance, physical approaches such as sedimentation, absorption and membrane fractation, or chemical processes such as coagulation and chemical precipitation are commonly considered at higher cost and lower efficiency. Energy is one of the most essential needs in the fundamental demands of human beings. It is also considered to be the main source for the development and growth of economics for the improvement of living standard. According to Sharma and Lee, 2010, explained further that the output of MFC is limited, whereas higher internal resistance utilizes significant amount of energy generation in MFC. Now let's see the literature review. For 2.1 microbial fuel cell, microbial fuel cell utilizes the natural metabolism of microbes to generate electrical energy. The two compartments contain respectively the two electrodes, which are the anode and the cathode. The two compartments are internally separated by an electrolyte and are connected externally via electrode through a conducting wire. For single chamber of MFC, we could be able to see from this slide, as mentioned by Saravanan and Karthikeyan 2018, single-chambered MFC involve only the anode compartment, in which there is no complete cathode compartment and proton thread films may be included. Dimick and Teckle stated that the design of single chamber is very easy to scale up in comparison to the two-chambered of MFC and have recently discovered an extensive interest in utilization and analysis. For dual chamber of MFC, the standard design of two-chamber MFC run in batch method but also able to operate in continuous mode and are currently used only in laboratories. As explained by Parker 2016, proton exchange membrane or PEM such as NEPON 117 has the function of separating the liquids in each chamber and allowing protons to transfer from anode to cathode. For leachate treatment by using microbial fuel cell. Using microorganism as a biocatalyst, it can convert biochemical energy to electrical energy. Although for years, MFC has been a marginal scientific issue, MFC have been catching up with other concepts of bioconversion in recent years. As stated by Yu et al., MFC that function organic wastewater as a result of generation of electricity has some advantages compared to other wastewater treatment methods because MFC can directly convert high conversion energy to electricity, operate at low temperature, generate less excessive sludge, and thus minimize sludge treatment or disposal. Let us see the landfill leachate overview. According to Icbhe et al., leachate is categorized as a fluid containing extracted dissolved matter and a suspended matter which passes through a landfill. Ganesh mentioned that generally a landfill consists of a liner at the bottom whereby the soil layers covering the daily accumulated waste, the production of leachate and extraction system, and landfill gas collection system. Let us see the methodology. So from the figure we see over here, this is UASB MFC hybrid system. From the figure we can see upflow microbial fuel cell configuration, influent, peristaltic pump, anaerobic sludge, salt bridge, aerobic part, cathode road, voltmeter, anode road, and effluent. The experiment was carried out in two separate upflow MFC made up of acrylic transparent material. Each reactor consisted of 4-liter capacity anaerobic anodic compartment and 4-liter aerobic cathodic compartments. All operational parameters of MFC are given in table 3.1 as mentioned just now. The total height of the reactor was 40 cm, and the distance between the anode and cathode was 12 cm. Up to 50% volume of anode compartment of the MFC generator was inoculated with homogenized anaerobic sludge, and SN solution was used as fuel at a flow rate of 0.4 liter. Reactor was operated in an upflow mode with all influent feeding at the base, and effluent was collected from the top of the reactor. 5 carbon rods were used as anode made from waste batteries carbon, each with a length of 55.17 mm and diameter of 8.02 mm, and was spaced 2 mm apart. Area of single carbon rod was 2.78 cm squared, and total area of anode assembly was 13.9 cm squared. Let us see the result and discussion. For pollutant removal, based on the study made by Bhatti, the hybrid system is extensively used to treat COD in industrial wastewater. The study found that by utilizing this hybrid system, it is able to achieve promising results in contaminant reduction. Furthermore, the nitrogen removal is one of the capabilities of the MFC. For the advantages of the system, microbial fuel cell MFC uses microorganisms such as bacteria as a catalyst that directly convert chemical energy to electrical energy. The hybrid of the two systems allows for stable and more efficient operation. MFC can be utilized as a post-treatment technology following the UASB process. As a result, this UASB MFC hybrid system can maximize energy recovery and producing an effluent quality that meet the environmental standard. Limitation of the system: the need of around 10% to 30% of the volume to be inoculated with active granular biomass during startup operation, where the effect was more significant when treating refractory and complex wastewater. Thus, pre-treatment is important prior to the system utilization, where it can increase the substrate biodegradability for better inoculation, particularly on wastewater treatment. Future perspective of MFC. He et al. Stated that future research will focus on the development of MFC in sustainable wastewater treatment, which emphasizes on metabolism mechanism, design and architecture reactor, MFC stack, power collection and utilization, and synergistic effect with other wastewater treatment technology. Besides, there is a need to think about low power densities in MFC service through existing design optimization to reduce the losses caused by over-potential activation of mic and concentration. MFC has various applications based on power generation. Conclusion: the use of a hybrid microbial system can be a way to improve and overcome the limitation of regular MFC, while at the same time boost the efficiency of contamination removal in various wastewater emission. UASB MFC have the following benefit. It is a stable and efficient system operation. It reduces energy consumption in water treatment processes. It reduces the amount of sludge produced. It maximizes energy recovery in leachate contaminant degradation. And it has a high DOD, COD, and SS removal efficiency. However, the limitation of the system comes from the slow retention time needed for the high percentage removal of contaminant. That's all from me. Thank you very much.